good? All right. All right, kiddos, let's try to plow through the rest of these word problems. So I'm not going to delay so we can make the most of all of our class time today. So we're going to pick up where we left off yesterday. I didn't hear back from anybody yesterday, so I'm assuming that once I cut you loose and you were on your own, you were able to finish out those problems. Your silence just forces me to assume that no news is good news. So we are picking up on number 16. So we're going to continue the exact same way that we did yesterday. So the assignment that we may end up having to tweak it a little bit, but on your lesson plan sheet, it's going to be 8.4C. We're going to work on numbers 16 through 22, although some of those were, one I know we're going to have to skip for sure because they didn't put enough information in the problem, and then maybe another, if we have time, we'll tackle it. But we're going to start on number 16. So get your pencil, your paper, and your calculator ready to go. So just like yesterday, we're going to read the problem in its entirety to try to formulate some kind of a scenario in our head. Tony hiked to the top of a hill having an elevation, that means up and down, that means like altitude, of 428 feet. She can see the peak of a mountain. I guess this is kind of, maybe this is her. This must be Tony in the picture. She can see the peak of a mountain 42 degrees up from where she's sitting. So from here, she's looking up at a 42-degree angle, and she's looking at the top of the mountain. If the mountain peak is 3,640 feet away from her, how tall is the mountain? So let's start with, here we started, this is the hill. And here's Tony at the top of the hill. Okay, I think she's actually sitting, but here, we'll make her little feet dangle. There, her feet are dangling. Okay, here we go. It looks like she's got several legs, but that's okay. Okay, she hiked to the top of this hill. The hill has an elevation of 428 feet. So that means the altitude, straight up and down. What was that, 428. Okay. And she can see the peak of a mountain. So we know over here we got a mountain, maybe with a little snow or something. Okay. She's looking at the top of a mountain. From where she is sitting, as she's looking up to the top of the mountain, that's a 42-degree angle. So from here to here. Okay, so what we have to do is we have to have this line that is parallel to the ground. This is a 42-degree angle. The mountain, the next thing that we're told is the mountain peak is 3,640 feet away from her. 3,640 feet away from her. So from here to here is that distance. So the question is, how tall is the mountain? Okay, so the ultimate answer, not the first answer that we're going to find, but the ultimate answer that we're looking for is the height of the mountain. So that's like we're looking for this number right here. Okay? Now, what we're going to be dealing with first is this right triangle that we created. Okay, so if you need to, you can extract it out of the busyness of our diagram, this is a 42-degree angle right here. This is 3,640 feet right here. I'm going to try to find this. That's going to give me this distance, okay? And then to find the distance of the whole mountain, I just got to come back and add this 428 feet, okay? So, but let's find this one first. So in relation to this angle, the parts of this right triangle that I have is opposite and hypotenuse, so that tells me that we're going to use sine. So the sine of a 42-degree angle equals opposite, which is x, over hypotenuse, which is 3,640 feet, okay? So to find x, if x is being divided by 3640, we're just going to do the opposite. We're going to multiply both sides by 3,640 feet. All right, so we just do this. Work on your calculator. 3,640 times, just hit the sign of 42. And so x equals, I'm going to write it the other way instead of trying to figure out how long. Okay, 2,435.635407. Okay, now don't clear this number out of your calculator. You don't want to have to type it again. All right, this is this distance right here. But the question is, how tall is the mountain? So I need to add to this number, this 428 feet that she's up, okay? So we're going to add 428 feet. Okay, so we left this number in our calculator, so now all you got to do is go plus 428. All right, so now this number equals 2,863.635407 feet. So x is approximately, what were we rounding? I think we were rounding to 2 decimal places yesterday. Yep. Solve rounding answers to 2 decimal places. Yep. Okay, so x is approximately 2,863 point. So this is the number that's either going to stay a 3 or go up to a 4. So this 5 right here makes that 3 round up to a 4. So this is about how tall the mountain is, okay, approximately, because it's a rounded number. All right. You guys having fun yet? All right, so we're going to do 17. Let's see here. Okay, so create a picture in your head. Okay, we've got 2 boats that are approaching a lighthouse. Okay, so I got a lighthouse. I got 2 boats that they're both approaching it from opposite directions. The driver of the first boat can see the top of the lighthouse at an angle of 32 degrees. Oh, sorry, 32 degrees. While the driver of the second boat sees the top of the lighthouse at an angle of 37 degrees. If the lighthouse is 75 feet tall, how far away are the boats from each other? So let's draw out the picture. All right, so here's my lighthouse. Here's my beacon of light right there. Here's one boat. I'm going to make it a sailboat because we just like to sail. And then here's another boat, another sailboat. Okay. So now let's plug in some numbers. We've got 2 boats that are approaching a lighthouse. Gotta have some water. Oops, he's not in the water. Oh well, use your imagination. Okay. He could be in the water. All of this is water, right? Okay. It's not an art class. So the driver of the first boat can see the top of a lighthouse at an angle of 32 degrees, okay? So that means that he's looking up at a 32-degree angle. So I make that right triangle, okay? The driver of the second boat sees the top of the lighthouse at an angle of 37 degrees. So make another right triangle. So he's looking at, let's clean this out a little. So he's looking up 37 degrees. So obviously he's a little closer. But okay, if the lighthouse is 75 feet tall, so that's this is my lighthouse right here. This is 75 feet. How far away are the boats from each other? Okay, so hopefully you can see the two right triangles in here. So however far this boat is from the lighthouse, and then however far this boat is from the lighthouse, those two numbers added together is going to be how far apart they are from each other. This is from here to here. This is what I'm looking for. That's how far apart they are. Okay, so let's just extract one triangle at a time. Okay, so let's take this one. This is my 75-foot lighthouse, and then here's my 32-degree angle. And I'm looking for, I want to know this distance right here. Okay, so we're going to solve for that. So in relation to this angle, I have opposite and I have adjacent, so that tells me that I'm going to use tangent. So the tangent of a 32-degree angle, tangent equals opposite over hypotenuse. Okay, so it's always fun when your variable is down in the denominator. We got to get it out of the denominator. So we're going to multiply both sides by x to get him up in the numerator. Actually, I cleared my fractions. And then from here, let me just clean it up a little bit so you can clearly see what I'm going to do. Okay, from here, to isolate x and to get x by itself, I would use the opposite of, he's being multiplied, so I would just divide both sides by the tangent of 32 degrees. Just basic algebra. Those cancel. X equals whatever this number is. Okay, so that's when your calculator takes over. So you get 75 divided by, just hit tangent, 32 equals, so this is 120.0250897 feet. Okay, hang on to that number. All right, so let's extract, let's do the same thing with this one right here. So now we're going to work with this right triangle. This 75 goes here. That's my, this is my lighthouse. My 37-degree angle is here. I need this portion of the right triangle, so that's where my x is going to go. So the same thing. I have opposite and adjacent, so I'm just going to take all the same steps. The tangent of 37 degrees equals opposite 75 feet over adjacent. Okay, I take the same exact steps here and multiply both sides by x. Okay, and then I'm going to end up dividing both sides by the tangent of 37 degrees. I'm going really fast. I hope you guys can, and I'm not writing out every step, but I'm pretty confident that you can follow. So these cancel, leaving me with nothing but x on the left side. On the right, all that I have left on top is 75 feet. On the bottom, I have the tangent of 37 degrees. Okay, so let your calculator do that for you. 75 divided by the tangent of 37. 99.9 0.528366162. Okay, now, hopefully you guys, and don't exit that out of your calculator, okay? Just keep that in your calculator. Hopefully you have noticed that I have not rounded yet, and hopefully you remember why. So I told you yesterday, when you're dealing with several numbers that you're going to have to do something with, whether you're adding them, subtracting them, dividing them, or multiplying them, you don't round until you're completely done, okay? I'm not going to round this number and round this number and then add them, because my answer is not going to be as accurate, okay? So we do not round until we are done doing all the math that we're going to do, okay? So this number is this distance, okay? So I need to add these two numbers, all right? This is my 120 point whatever number. This is my 99 point blah, 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 blah number, okay? So I need to add them, and then I'm allowed to round. Okay, so this number is already in your calculator, so you should have left it there, okay? Again, the less times you have to input a long string of numbers, the better, all right? You have less chance of error. So from here, I'm just going to go plus, and then I'm going to very carefully put in 120.025. Oh, see, I did that wrong. 0250. Actually, 0. O is not a number, but anyway, 897. Okay, so I have 219.5534513 feet. Now I'm ready to round. That is my final number, okay, after I've done all my mathing. This is my final number. This is the sum of these two, so now I can round. So this is the number that's hanging in the balance, either that stays a 5 or goes up to a 6. So this guy tells me he's staying a 5. So they are approximately 219.55 feet apart from each other. All right, a lot of steps. Might have taken, up a lot of paper, but that's okay. 18, we're going to skip for now. If we have time, we'll come back to it. If not, we're just going to disregard it. It's just going to take a lot of time, and I would rather do more problems, different types of problems, and use up time that way. So we will skip 18 and look over at 19. Well, the great thing about this is that you can come back and watch it again. You can pause it, do whatever you need to. Pretty much at this point in the game, all I need you to do is stay engaged in school, and you're going to be fine. Okay, so we're going to skip 18. We're going to look over at 19. Okay, so Jared is walking up, he's walking 4 feet up a ramp the ramp is at a 15-degree angle. His friend is walking 5 feet up a ramp in the opposite direction at a 25-degree angle. If the bottoms of the ramp are 6 feet apart, what's the distance between Jared and his friend once reaching the top of the ramp? So we have 2 ramps going opposite directions. We know that the ramps are 6 feet apart. So the distance from here to here is 6 feet. Okay? And we've got Jared right here. He could be like our Jared, someone give him a big old beard. All right? And he walked 4 feet up this ramp, at a 15-degree angle. His friend is walking 5 feet. So this is Jared's friend. Okay. And he's going 5 feet up a ramp at a 25-degree angle. The bottoms of the ramp are 6 feet apart. Yes. What is the distance between Jared and his friend once they reach the top of the ramp? So the final number that we're looking for is, so once he finishes, he's going to be right here. Once his friend finishes, he's right here. So the question is, what is that distance? Okay? So hopefully you can see what we're going to do is we're going to find this, the length of this side of the ramp or our triangle, and then we'll add in the 6 feet, and we'll find this distance right here. So we'll just add these three numbers together. That will be the total distance as far as how far apart they are, okay? So I'm just going to set it up, and how many do we have? 19. Well, we might can quickly run through it. Okay, so I'm looking for this. So in relation to this angle, I'm looking for adjacent, and I have hypotenuse. So adjacent and hypotenuse means cosine. So right here, well, y'all can probably see those. Those aren't too busy. Let's not waste time doing that. Okay, so with this triangle right here, I'm going to do the cosine of 15 degrees equals adjacent over hypotenuse. Okay? So actually, I am going to let you finish this one. All right? And over here, I need this side of the ramp. So in relation to this angle, I have adjacent, I'm looking for adjacent, and I have hypotenuse. So that's going to be cosine again. Cosine 25 degrees equals adjacent over hypotenuse. Okay. So I'm going to let you finish this one. So do this math, find this number, do not round. Do this math, find this number, do not round. And then add this number plus your 6 feet plus this number and then round. Okay? I've made that about as clear as I possibly can. All right? So I'm going to let you finish that one, and we're going to set up 20 is the one that they missed. There's a little bit of information missing. They should have given us another angle, but they didn't, so we're going to have to skip it.
I want to know if they still need to do 18 on their own.
If we have time to come back to it. Only if we have time to come back to it. So I'm trying. If we don't, then we're just going to skip it. It's pretty busy. Very, very busy. Okay, so we're going to skip 20. We're definitely going to skip 20. For sure. So let's look at, so turn your page, let's look at 21. All right. Stephen wants to hang a banner between two trees on his property. Okay, so we got two trees on the property. He wants to put a banner in between them. He knows that one tree is 33 feet tall and the other one is 20 feet tall. A path goes between the two trees. If he calculates the angle of inclination from the center of the path to be 55 degrees to the top of the 33-foot tree and 35 degrees to the top of the 20-foot tree, how far apart are the trees? So just to kind of give you a picture, we've got one tree, and then we've got another tree, and then we got a walking path going in between them, right? Okay. One of the trees is 33 feet tall, so we'll give that to this guy. 33 feet. The other one is 20 feet. We got a path that goes between them. The angle of inclination from the center of the path to be 55 degrees to the top of the 300. Okay, so from the center of the path to the top of the tree, that angle of inclination is 55 degrees. Yes, the 55 degrees goes to the top of the 33 foot. Okay, so I just ran right through that number, but we'll fix it. Okay, and then the angle of inclination to the top of the 20-foot tree is 35 degrees. Okay, the question is how far apart are the trees? So this is the distance right here that I'm looking for. Okay, so I need to find that, and I need to find that, and then we'll just add them together, right? So this is very busy, so we can very easily just draw a nice, clean, right triangle just to bring clarity. Looking for that distance. This is my 20-foot tree. Okay, so all you got to do is find this number, do not round it, find this number, do not round it, add them together, and then you can round. Okay? Last one, maybe. Let's do 22, and then or at least get it set up, and then we'll see how much time we have left. Okay, 2 ramps, 22. 2 ramps for toy cars are built facing each other, and the ends of the ramps are touching. The first ramp is 38 inches long, the second ramp is 45 inches long. If the point where the ends touch is 26 inches above the ground, what is the angle of each ramp? So we've got 2 ramps. Okay, this is number 22. So this is what we have. We've got 2 ramps facing each other. Their ends are actually touching, okay, so there's not a distance or space between them. The first ramp is 38 inches long. Okay, so what that means is this one right here, okay? That can be confusing. That can be very confusing sometimes. You could very easily put it here, but what they're meaning, what this problem is meaning as far as the length goes, is on the ground, okay? So this is 38 inches. The second ramp is 45 inches. The point where the ends touch, that's right here, is 26 inches above the ground, okay? This is obviously the ground, that's where the ramps are sitting, okay? So the distance from the top to the ground is 26 inches. What is the angle of each ramp? So then I'm looking for 2 answers here, the angle of each of my 2. So I'm looking for theta on this right triangle, and then I'm going to look for theta over here on that right triangle, okay? So if it helps, You can split them apart and make two problems because really we have two problems. Okay? You don't have to do this, but if it may help. Okay, so we're going to tackle this triangle right here. I'm looking for an angle. I know that number and I know that number. Okay? This angle over here, this triangle over here. Okay, so there are my two problems. So in relation to theta on this one, I have opposite and adjacent. So opposite and adjacent means tangent. So I've got the tangent of theta. It's important that you put theta. You have to represent your angle, okay? And it's important, again, that we have an equal sign. Tangent is opposite over adjacent, so that's 26 inches over 38 inches. And then the same way over here, opposite and adjacent. So I've got tangent theta equals opposite, which is 26 inches over adjacent. Okay, so what's important here is that you remember you're looking for an angle, right? I'm looking for an angle. Right now we're measuring angle in degrees. As soon as you realize I'm looking for a degree, I have to shift on my calculator, okay? That's key. You have to use the inverse function when you're looking for a degree. So you're just going to go shift, tangent, plug in the fraction, okay? And then your answer has to reflect that it is degree. Don't forget your degree symbol, okay? You guys are much better at it. You're getting better at it and not forgetting it, okay? Because without it, it means something totally different, all right? So, and then round, okay? Follow your directions for rounding. They're given to you for a reason, all right? So this actually has two answers. You're going to give me however many degrees and however many degrees rounded, okay? So as far as 18 goes, I don't know if we could get that set up. We can try. I know you guys have, some of you guys have Spanish right after this, but what do we have, about 5 minutes? Let's give it a shot. This one is really kind of hard to piece together, and but I can help you get it set up, and then let's see. Okay. So in an effort, okay, so let's read the problem quickly. In an effort to find the distance between each other, two hiking groups use a cell phone tower as a reference point, okay? So you get two people out in the woods. They're in different locations, but they're both looking at the same tower, okay? The tower is directly north of Team A, and they measure the angle from their position to the top of the tower at 39 degrees. Team B, which is directly west of the tower, measures the angle to the top of the tower from their position as 32 degrees. If the tower is 100 feet tall, okay, so it's going to be true for both, that's a constant number. The tower is 100 feet tall. How far away is Team A from Team B? So let's take care of each team separately first, okay? So let's draw a triangle for Team A. Okay, so here's the tower right here. This is the tower. And we know that it's 100 feet tall. Okay, and Team A is looking at the tower at an angle of 39 degrees, right? Yes. So here they are. This is Team A right here. This is a little group of people, okay? They're looking up the tower. Okay, so, and then we're trying to figure out how far away they are from the tower. So I'm looking for this, all right? And so then let's do the same thing over here. Okay, this is the tower, the 100-foot tower again. All right, but here we've got team B, and we want to know how far apart they are from the tower. They're looking up at 32 degrees to the tower. So let's see how far apart they are from the tower. So let's do the math here. In relation to this angle, we have opposite and adjacent. Okay, so we'll do the tangent of 39 degrees equals opposite over adjacent. Okay, so we got to get this guy out of the denominator. Clear your fractions by multiplying both sides by x. Okay, we'll do the same thing over here. Opposite and adjacent, so we do the tangent, 32 degrees equals opposite over adjacent, and we'll find that distance there. Okay, now the question is, how far is team A from team B? Okay, so let's make another triangle. All right, so I'm going to make this the tower, like if we were looking down from the sky. That's the top of the tower. And we know that the tower, if we go back to the beginning of the problem, the tower is directly north of team A. So I'm going to put team A down here, south of it. And we know that it's north of team A. Team B is directly west of the tower. So they're going to come out here west. The question is, how far are they from each other? This is what I'm looking for. Okay? So once you find these answers, they get plugged in here. Okay? So this right here, this number, this answer that you find, not rounded, don't round, okay? This number is how far team A is from the tower, okay? So this right here is gonna go, okay, I'm fixing to make a mess out of this board. This answer right here goes right here, because this is the distance team A is to the tower, okay? Once you find that answer, you're going to plug it in here, because this is team A and the tower, okay? Once you find this answer over here, this is how far team B is from the tower. Once you're done with the math there, not rounding, that answer is going to go right here, because that's how far team B is from the tower, okay? So then you're going to plug those in here and here, not rounding, and we're going to find hypotenuse. So then you're going to kick in the Pythagorean theorem and find C, okay? So now again, do not round anything until we are completely done. So yes, you're going to be squaring huge numbers, but your calculator can handle it, okay? Because these numbers that are going to get plugged in here are not going to be rounded numbers, okay? So we're going to have this squared plus this squared equals, and then you're going to square root it, and then you're allowed to round, okay? Once you get down to C equals on the Pythagorean theorem, then you're going to round, but not until then, okay? All right, so we did squeeze it in. So that one is just a bonus. That's some bonus fun right here for you today, okay? So I got to let you guys go. I will see you tomorrow. I will give you a heads up on the quiz that you're going to have on Monday, and then we're going to walk through the review that you're going to do tomorrow. Some of the stuff is pretty old, so I'm hoping to be able to do some of the problems with you and kind of jog your memory on some things. So have fun. Enjoy. See you tomorrow.